As promised, let's go ahead and do one more example of this. We're going to solve the following trigonometric equation involving a frequency modulation. This is the cosine of 4 theta is equal to root 2 over 2. So the first thing that we'll need is the general solution of simply the cosine being equal to root 2 over 2. So on our unit circle, we would be looking for two angles in quadrants 1 and 4, where the x-coordinate is equal to positive root 2 over 2. Referencing your unit circle if need be, please feel free to do so. And writing down the general solutions, in quadrant 1, the angle would be pi over 4. And then we'll generalize that solution by saying plus 2k pi. Or, in quadrant 4, the angle that we're looking for is 7 pi over 4. And then once again generalizing that plus 2k pi. Next, we'll finish solving for theta in both of these equations by taking 1/4 of both sides of each equation. This will give us theta is equal to 1/4 of pi over 4 will be pi over 16. And reducing, this will be k pi over 2, reducing the 2 over 4 to an over 2. Doing the same thing in the second equation, 1/4 times 7 pi over 4, we get 7 pi over 16 plus 2k pi times 1/4 is 2k pi over 4. We reduce the 2 over 4 to get k pi over 2. Now, according to what we said in the last video, there will be a total of 4 values of k that will actually work. The 4 values of k are going to start with 0, and they are going to end once we go up one at a time and arrive at our 4th value. Let's see what we get for each of these. For k equals 0, this one's going to be pretty straightforward because it's just going to zero out the k pi over 2. So we'll get pi over 16, or theta equals pi over 16, or theta equals 7 pi over 16. At k equals 1, we get pi over 16 plus 1 pi over 2. Call that pi over 2. We'll also get a common denominator for these so that we can add them together. Pi plus 8 pi will give us 9 pi over 16. Doing the same thing for the second part, 7 pi over 16 plus 1 pi over 2. Once again, we'll need a common denominator, so we'll multiply the second by 8 over 8. 7 pi plus 8 pi will give us 15 pi over 16. Again, both of these angles still lie within 0 to 2 pi. For k equals 2, our first solution gives us pi over 16 plus 2 pi over 2. Normally I'd say reduce that, but we need a common denominator anyway. So we'll go ahead and multiply that by 8 over 8. Pi plus 16 pi for the numerator will be 17 pi over our common denominator of 16. Or, doing the same thing for the second solution, the 7 pi over 16 plus 2 pi over 2. We get a common denominator once again by multiplying by 8 over 8 for that second fraction. 7 pi plus 16 pi will give us 23 pi over a common denominator of 16. And finally, for k equals 3, this will be theta is equal to pi over 16 plus, now we'll have 3 pi over 2, the common denominator once again, of 8 over 8. That'll give us a common denominator of 16. And in the numerator, we have pi plus 24 pi. That'll be 25 pi for the numerator, 16 for the denominator. The other one, 7 pi over 16 plus 3 pi over 2. Once again, common denominator of 8 over 8. Common denominator is now 16. We have 7 pi plus 24 pi for a total of 31 pi over 16. 31 pi over 16 is just barely below 2 pi, to let us know that if we were to go on to k equals 4, we would be exceeding 2 pi, which is also made obvious to us in this statement right up here. if we were to plug in k equals 4, we would have 4 pi over 2, which is 2 pi. We're adding 2 pi to a positive angle. That's going to give us something outside of the interval. So final answer for this one. Theta is equal to pi over 16, 7 pi over 16. That was from k equals 0. 9 pi over 16, 15 pi over 16. That was from k equals 1. 17 pi over 16, 23 pi over 16. That was from k equals 2. And 25 pi over 16, 31 pi over 16. That came from k equals 3. K equals 0, k equals 1, k equals 2, and k equals 3. Good stuff.